Architecture Engineering Assignments Help. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@architectureassignmenthelp.com or reach us at https://www.architectureassignmenthelp.com. 1 proposal for a combined heating and cooling system for a home is a so-called ice maker heat pump. It is shown in the sketch. The heat pump is operated using electricity during the heating season. It withdraws heat at 0 OC from a pool of water. This is the low-temperature heat source. It delivers heat at higher temperature to heat the house. As heat is transferred from the water, ice is formed. In practice, there are a series of pipes in the water. The pipes contain cold refrigerant. Ice forms around the outside of the pipes. Because of the rather low temperature of the ice and water, the COP, ratio of heat delivered to electrical input, of the heat pump is only 2.5. To change phase from liquid water to ice, the internal energy change is approximately 334 kJ/kg. Neglect the change in volume for this process. The home requires 60 by 106 kJ of heat during the winter and 30 x 106 kJ of cooling, amount of heat transferred for cooling, for the summer. In the summer, the heat pump is turned off and the melting ice is used to provide cooling for the home. Architecture Assignment Help. A. How much ice is formed over the heating season? Is it adequate to meet the cooling needs? Answer. For heat pump, COP equals QH/W equals 2.5, and QH equals W plus QC, so the QC equals 0.6 QH equals 0.6 * 60 x 106 kJ equals 36 x 106 kJ. The ice is formed over the heating season is increment U water ice equals QW, here W equals 0. Increment U water ice equals mice * increment U water ice equals Q, so mice * equals Q/increment U water ice sad face 36 by 106 kJ / 334 kJ/kg equals 107,784.4 kg. In summer condition, the heat pump is turned off, and the cooling needs 30 by 106 kJ. The ice should be adequate to meet the cooling needs if the ice container's insulation is good enough to keep ice from melting during spring. Additionally, the performance coefficient of the mechanical system used to transfer heat from home space to ice must be better than 83%, is equal to 30 times 106 kJ/36 x 106 kJ. Architecture Assignment Help. B. Compare the electrical energy consumed for the ice maker heat pump system with a conventional system. In the latter, the heat pump has a COP of 4.0. This is higher than the ice maker heat pump because the outside air is usually above the freezing point. In the conventional system, the heat pump is also used as an air conditioner in the summer, where the air conditioning COP is 3.0. Answer. For the ice maker heat pump, COP equals QH/W equals COP equals QH/W equals 2.5, and the electricity energy consumption, W equals QH/2.5 equals 24 x 106 kJ. For the conventional system, winter it needs electricity, W1 equals QH/4 equals 15 x 106 kJ. In summer, it needs electricity, W2 equals QC/3 equals 10 x 106 kJ. The conventional system needs totally 25 x 106 kJ. From our calculation, it shows that the ice maker system will save 1 x 106 kJ electricity energy. Architecture Assignment Help. C. Comment on the feasibility of the ice maker system for home heating and cooling. Answer. 1. The container of ice will be huge. We can estimate the ice volume, and we need a 110 cubic meters, such as 4.8 m times 4.8 m times 4.8 m, size cubic tank to hold it. It at least needs a large-scale storage space. Additionally, the ice container should be insulated so well in order to keep the ice from melting during spring period. 2. The mechanical system that is used in the ice maker system will be some complicated and highly cost. It needs to consider a lot of technical problems in order to increase the system's performance. 3. Actually, in summer condition, even if the heat pump is turned off, some electricity energy still needs to transfer heat between the house space and ice. So the ice maker system save energy comparing with conventional system may not happen. So, the ice maker system is not so feasible for general conditions. For example, it may not be used in a single house of which heating and cooling energy needs are not so big. This system will increase the first cost significantly. It may be applied in some special large buildings, which can afford the first and operation cost increasing. Architecture assignment help. 2. In summer, one person leaves her room with an opened cooker in which fully contains water. Some days later, she comes back home and found that some of the water in the cooker has been evaporated. The room volume is 50 cubic meters, and current indoor air temperature is 35 OC. Assume the room facade is insulated so well that there is no heat transfer through the facade. Also, the room is sealed well with no air leakage. A. If the indoor air is saturated with vapor, how much vapor does the indoor air contain, kg? Answer. From Table K, in page 353, we find the specific volume of the saturated vapor at 35 OC has V equals 25.22 m3/kg. Then the vapor contained in room air is mv1 sadface 50 cubic meters / 25.22 cubic meters per kilogram equals 1.98 kg. Architecture assignment help. B. The person feels that the indoor air temperature too hot. She turns on the air conditioner to cool the air. 2 hours later, the indoor air temperature becomes 25 OC. How much water condensed from air during the 2 hours? Please don't consider the vapor generated by the person. Answer. From Table K, in page 353, we find the specific volume of the saturated vapor at 25 OC has V equals 43.36 m3/kg. Then now the vapor contained in room air is mv2 sadface 50 cubic meters / 43.36 cubic meters per kilogram equals 1.15 kg. The condensed water is water condensed equals mv1 mv2 equals 0.83 kilograms C. If the COP of the air conditioner is 3.0, how much electricity energy, kJ, was used to cool down the air from 35 OC to 25 OC? Assume that the person stayed in the room during the cooling 2 hours, and her heat amount that transferred to. Architecture assignment help. Room air is 100 W. Room air density between 35 OC to 25 OC assumes constant as 1.17 kg/m3, and specific heat of air CV equals 700 J/kg.K. Answer. We set the air at 35 OC as state condition 1, and the air at 25 OC as state condition 2. Take the room air, including the vapor, as our control system, then we have increment where equals QW, here W equals 0. Then, increment where equals word 2 where 1 equals mare asterisk CV air asterisk, T2 T1, plus water, condensed asterisk, UW, 2 UV1, sadface 1.17 kilograms per cubic meter, asterisk, 50 cubic meters, asterisk, 0.7 kj/kg.oc, asterisk, 250 C35 sadface 1.17 kilograms per cubic meter, asterisk, 50 cubic meters, asterisk, 0.7 kj/kg.oc, asterisk, 25 OC, plus, 0.83 kilograms, asterisk, 104.88 kj/kg 2423.4 kj/kg equals 0 C35 OC.